Welcome to Maths 123. In this question, we have to prove that a plus ar square plus so on plus ar raised to power n minus 1 is equal to a into r raised to power n minus 1 divided by r minus 1 for all r greater than 1 and n belongs to natural number. Left hand side is equal to right hand side. We can prove by two methods. So first method here, we'll take left hand side. So we know my left hand side is equal to a plus ar square plus so on ar raised to power n minus 1. And here first term is equal to a and the common ratio is equal to ar upon a, which is equal to r. So mean this is my GP and here we have n terms of this GP. So Sn, let the sum of this GP is Sn, which is equal to a plus ar square plus so on ar raised to power n minus 1. Now let's multiply both sides by r. So we'll get r into Sn is equal to, multiply this with r, ra plus ar square plus ar cube and so on plus ar raised to n. Let me take this equation as 1 and this as my second equation. Now 2 minus 1 will get rsn minus sn is equal to ra plus ar square plus ar cube plus ar raised to power n minus a plus ar square and so on plus ar raised to power n minus 1. And here my previous term will be ar raised to power n minus 1. If we subtract these, this will get cancelled with this will get cancelled with this, and this also will get with another next term with this, and this will get cancelled with this. So here we will be left with ar raised to power and this thing and minus a. So this will become equal to a into r raised to power n minus 1. And if we solve this, we'll get Sn is common, Sn r minus 1 is equal to a r raised to power n minus 1. So Sn is equal to a r raised to power n minus 1 divided by r minus 1. So hence proved. This only we have to prove. Second method of proving that the sum of all n terms of a GP is equal to a r raised to power n minus 1 divided by r minus 1 is mathematical induction. So here we have to take few steps. Let's discuss all those steps step one by one. So first step here, we have to take equation as Pn. So it means this will become ar plus ar square and so on plus ar raised to power n minus 1 is equal to a into r raised to power n minus 1 divided by r minus 1. Now the step 2 is we have to put n is equal to 1. So let's see what the left hand side is equal to right hand side. So left hand side here is equal to a into r raised to power 1 minus 1, which is equal to a into r raised to power 0, which is equal to 1. So let's see right now right hand side, a into r raised to power 1 minus 1 divided by r minus 1. This will get cancelled with this will get a. So left hand side is equal to right hand side. Pn is true for n is equal to 1. Now in step 2 we have to assume that Pn is true for n is equal to m. Means this Pm dot a plus ar square and so on plus ar raised to power m minus 1 is equal to a into r raised to power m minus 1 divided by r minus 1. This I'll take as equation number 1. So step 3. Now we have to prove that p into m plus 1 is also true. That is, we have to prove that Pm plus 1, that is AR plus AR square so on plus AR raised to power m is equal to A into R raised to power m plus 1 minus 1 divided by R minus 1. So here we have to prove this equation. So for that I'll take left hand side, which is equal to AR plus AR square and so on AR raised to power m. So this I can write as AR plus AR square plus so on the previous term. First I write here m minus 1 plus AR raised to power m. So from equation 1 if we see, so this whole thing is equal to this. So I'll put this value here from equation 1. From 1 I can write this as AR raised to power m minus 1 divided by R, this plus AR raised to power m. So this will become AR raised to power m minus A plus AR raised to power m plus 1 minus AR raised to power m divided by R minus 1. So this will get cancelled with this. The A is common. I'll take this out. R raised to power m plus 1 minus 1 divided by R minus 1. And if we see this equation, so we can find out that this is my right hand side of the equation is equal to right hand side. So here also we have proved left hand side is equal to right hand side. So we can say that Pm plus 1 is true when Pm is true. So by the principle of mathematical induction, Pn is true for all natural number. Means the sum of n terms of a GP is equal to A into R raised to power n minus 1 divided by R minus 1. If you like the video, please give thumbs up. Do subscribe to my channel for more interesting videos and hit the bell icon for further notifications. Thank you.